So I would say the easiest approach here, it might be a little bit surprising, but because these are both roots and there's no need to do any squaring or anything like that, I would actually use our program solver. And usually solver is used for when x or s is to the first power, but solver does work for square roots in specific instances, specifically when there's only one solution. So the fact that it says what is the solution tells you that it could definitely be a good option. So let's go ahead and type in the left side, and it's important that you close the parenthesis. Otherwise, it's going to think the square root of, in this case, x plus 7. So we'll type in everything else, and then on the right side, we have 6 plus 4 root x. In that case, I don't really have to close it, but I will anyway. And we get our answer. Now, keep in mind, you're able to type in up to 5 characters, 6 if you're including a negative. So we could type point, and then that's already 1 character. So we'll go 1, 2, 3, 4, and that's all it's gonna let us do, even if I try to do more. So that would be acceptable. You could also choose to do 0.111, but notice it's only going to allow me to do 3 decimal places there because a total of 5 characters, and that totally would be acceptable as well. Now, we could instead do this in Desmos. So let's go ahead and take a look at that. And there's 2 approaches for doing it in Desmos. One of which is just typing it in the way that we see it, which usually is going to be the easier approach. So let's go ahead and try that. We'll use the keyboard that they have in the lower left corner because of the square root symbol. I find that to be a little bit easier. We'll type in X. Otherwise, it's going to get confused and think we want to use the slider feature, which we don't here. We'll type all this in equals 6 plus 4 root x again, and then we'll go ahead and press enter. And I actually didn't even need to do that. We'll go ahead and zoom in to find the point of intersection. Now the tough thing here is I can't really clearly see the answer. It's a little bit difficult. I might have to just kind of guess at this point, and I don't want to do that. I feel like I'd be a little bit hesitant there. So what you can do in that case is you can actually take this right side, and I did Control X to cut it, and I'll put it over here. And so now we have these 2 functions, the one that's on the left side, the one on the right side, and we're trying to essentially find the point of intersection. So let me zoom out till I can see these functions. There we go. So now let me zoom back in now that I know where I'm at. And we're going to find the point of intersection. And more specifically, we just want the x coordinate where they intersect. So you could click here, click label, and we can see it really clearly. And we see that 0.1 repeating. So we get our correct answer. Now, for those of you who are considering, well, what would I do on this if I were in my actual math class and I had to solve it by hand? And that's a great question. What you would do is you would say, well, I know there's only one type of s. They're both under a square root. I'm going to get s's to one side, numbers to the other. So let's say I take this 1 root s and I subtract it to the right side, but I still have a leading coefficient that's positive. That'll give me 3 root s on the right side. I'll put it over here. On the left side, I'm going to bring my constants to the other side, and I get 1 on the left side. To get the root by itself, I'm going to first get rid of that 3, which is more loosely attached than the square root is. Now I get rid of the square root, which is very directly attached to the s, by squaring both sides. And when I do so, I'm really squaring the numerator, and 1 times itself is 1, and I'm squaring the denominator, and I get 1/9. So instead of putting 0.1 repeating, I could just type 1/9, and we could see here in our calculator that that is equivalent to 0.1 repeating.